Okay, guys, I am back again with the next question, off of that other one. Okay, so I'm just carrying on from the previous question. Consider the diagram and answer the questions. Oh, answer the questions and give reasons for your answers. So, in the previous question, we spoke about congruency, and I had said that remember congruency was where it was like they gave you two triangles and they said the one triangle is congruent to the other triangle. This symbol here means congruent. Okay, and in this question, you'll notice there's a similar thing that's happening here, but except they've given us this symbol. This symbol here means similar. There's only, okay, I was about to say there's only one way. There's two ways to prove similarity. Okay, so just to contrast for you guys what similar and congruent means. Congruent means the two triangles are identical. Same size, same kind of triangle, same angle, same size and everything. That's congruency. The triangles are exactly the same in every way, shape and form. Okay? Then similarity means that they're almost the same. It's like one is a miniature version of the other, basically. It's like one is a shrunken down version of the other one. That's what similar means. So they will have the same, proportions, but one will be bigger and the other one will be smaller. That's what similar means. But it's still two triangles. They are, they still, maybe if they both isosceles triangles, they both be isosceles. If they both right angle triangles, they'll both be right angles, but one will be like shrunken down. So maybe you'll take the sides of the one and multiply the sides by 2 to get the other one, or divide the sides by 2 to get the other one. Okay. So basically what you need to know is that for similar triangles, you can prove that they have all angles equal. Or in other words, angle, angle, angle. Okay. And the other thing is that you can do is you can prove that the sides are in proportion. So in other words, you would have multiplied all sides by the same value to get to. So for example, if I give you a triangle that is 2, 3 and 4 centimeters, then I multiply all sides by 2. In other words, I enlarge it by a factor of 2. Then if I multiply 2 by 2, I get 4. Multiply 3 by 2, I get 6. Multiply 4 by 2, I get 8. Can you see that this is half of this? This is half of this. This. And this 4 is half of 8. So that means since I've multiplied this triangle by a factor of 2, it gives me another triangle which is bigger, but we say that it's similar because the sides are in what? Proportion. Okay, cool. So they want me to prove that triangle ADE is similar to triangle ABC. Okay, so remember I told you there's two ways to prove it, and that's angle, 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 or size and proportion. Now, just look at this question here. We don't have any information about any of the sides. Do you guys realize that? So the only thing we can do is prove that the sides are in proportion. Now, what I'm going to do is I'm going to break down. Do you see I highlighted one in red and then I highlighted the other one in purple? So what I'm going to do is I'm going to draw the two triangles. How do you make this? Okay, there we go. Hey. I'm going to draw the two triangles so that you can see them clearly. There's the one, the small one, ADE. And then there's another triangle here, ABC. Okay, and I need to prove that the three angles of those triangles are the same. The first things first is they told me that this angle is 58. Now, if you notice, if you can see it, can see that 58 degrees is there, and this is the same 58 degree angle there. So my first thing I would say is that angle A, or let's say in triangle ADE and triangle ABC, angle A is equal to angle A. The angle A in triangle ADE is equal to the angle A in triangle ABC. The reason I'm saying that is because it's the same angle. Okay, it's the same angle. So obviously if it's the same angle, it's equal to itself, isn't it? Right, so it's possible for me to say that. Now, they've also told me this other fact here, which is that DE, the line DE, is parallel to the line BC. Can you guys see that? DE is parallel to BC. Can you see? So what does that mean? That means I can use my fun rules. And if you notice here, I have angle B and angle D. If you notice, I have an F here. Can you see that F there? So I can then therefore say angle D1 is equal to angle B, which is equal to 60 degrees. My reason is corresponding angles are equal. Okay. And then now it's up to you how you want to do this last part. I will tell you guys the easy way, and then I'll tell you guys something that's a little bit less obvious, but I think it's even easier. Okay, the first obvious thing is, for the same reason that D1 and B are equal, I can also say that E1 and C1 are equal. Let me say angle E1 is equal to angle C, because they're also corresponding angles, ne? If you try and find the F on the other side, you'll see there's an F there as well. There and there. Can you see the F? So that means these two angles will be corresponding as well. So we can say corresponding angles are equal. Okay. But now I want to tell you something. If I have two triangles, honey, and let's call this triangle ABC and call this triangle PQR. And I know that this angle is equal to X and this angle equals X. This angle equals Y and this angle equals Y. If I can prove that two angles in the two different triangles are equal to each other, the third one will automatically be equal, because remember there's something called sum of the interior angles of a triangle, which says that if I have two angles, the third one will be 180 minus the sum of those two angles, right? So if this angle is X and Y and it's also X and Y in the other triangle, the third angle B will be equal to 180 minus X plus Y. And even Q will be equal to 180 minus X plus Y. So that means, since both of them are equal to 180 minus X plus Y, that means they are equal to each other. Okay, and the reason is angle B is equal to angle Q. And the reason is, that's not what I meant to write. Third angle of a triangle. That's the reason. So you could have also used that as your reason here. You don't have to use corresponding, but it's not wrong to use because they are actually corresponding angles. Right. Therefore, we can say triangle ADE is not congruent. We're talking about similarity here. Is similar to triangle ABC. And my reason is angle, angle, angle. Sometimes you'd see it written as angle, angle, angle. Okay. Whichever one tickles your fancy is fine. Okay, next question is asking, assume that triangle ADE is similar to triangle ABC. So even if you are not able to prove it in the previous question, let's assume it now. Let AE equal 4 millimeters. Okay, AE, okay, I'm going to erase everything off of here now. Let AE equal 4 centimeters. Okay. Let AC equal 16 centimeters. So AC is equal to 16 centimeters. Sorry, it's millimeters. Why am I saying centimeters? Okay. And then they're also saying BC is equal to 12 millimeters. BC is equal to 12 millimeters. Oh, and I regret erasing those two triangles that I drew. Okay, let's redraw them. So we had ADE, which was the small triangle, and then we had ABC, which was the bigger triangle. Okay, and we've now been told that AE is 4 millimeters. We're told that AC is 16. And we told that BC is Oh. Oh, okay, I changed the color. I was wondering why I couldn't see. Hey, I'm getting old. Okay. And now they want to know the length of DE. Determine the length of DE, which is this length over here. Okay, guys, what you guys should know is that the sides are in proportion. Remember I told you that, obviously this one is the smaller triangle. So if we're multiplying this triangle, this length, each length by the same thing, that means, what did I multiply? Okay, we can say AE is equal to, or if I take AE and I multiply it by 4, I'm going to get AC, right? Which means if I take DE and I multiply it by 4, I'm going to end up with BC. Are we together? Because the triangles are similar to each other, we know that the sides are in proportion. Once you've proven that the triangles are similar, you know that the sides for 100% sure will be in proportion, which means that all the sides will be multiplied or divided. All the sides of the one triangle will be multiplied or divided by the same thing to get the sides of the other triangle. So here I can see AE is 4 millimeters, and I must have multiplied 4 by 4 to get 16, which is the length of AC. So now I want DE, and I know that it's going to be multiplied by the same thing to get BC. I'm going to say DE times 4 is equal to BC. Now here's the catch. The gag is I know what BC is equal to. I know that BC is equal to 12 millimeters. So I can say DE times 4 is equal to 12 millimeters. Okay, therefore, what times 4 is equal to 12? DE will be equal to 3 millimeters. That is your answer. Here you can say sides in proportion. Okay, I hope that makes sense. Okay, moving on swiftly. Okay, convert the following. This question is so easy. Number 3.1.1. Very, very easy question. Look at this. Okay, so they gave us 99 degrees Fahrenheit and they want us to convert it to degrees Celsius. So they gave us the formula. Please use the formula. The degrees Fahrenheit is equal to degrees Celsius times 9/5 plus 32. Okay, and they gave us the degrees Fahrenheit as 99. So please just substitute the 99 into the place of the degrees Fahrenheit. Then we're going to solve for x. You're going to start by taking the 32 over. We're going to solve for degrees Celsius. We're going to take the 32 over. It becomes minus. 99 minus 32 is going to be 67 is equal to degrees Celsius times 9/5. Then, if it's multiplied on this side, when I take it over, it becomes divide. So I have 67 divided by 9/5 is equal to degrees Celsius. That's supposed to be a 9. So then, yeah. So then remember that when you're dividing by a fraction, you tip and times. So it'll be 67 times 5/9. Does 67 go into 9? Does 9 go into 67, I mean? No, it doesn't. No, it doesn't. Okay, so you're just going to use a calculator then. If I can find my calculator, that would be amazing. So you say 67 times 9 times 5/9. That will be 37,22 degrees Celsius. Okay, easy as pie.